Today, we're going to talk about a technology that sits at the very beginning of smartphones, AI chips, and modern electronics. It sounds complicated at first. Photoresist. Inside a semiconductor chip, there are billions of tiny circuits, each one thousands of times thinner than a human hair. So how do engineers draw such incredibly small patterns on silicon? The answer is photoresist. Photoresist is, simply put, a special material that changes its properties when exposed to light. During chip manufacturing, this material is coated as an extremely thin layer on a silicon wafer. Then, a plate with circuit patterns on it is placed on top, and strong light is shined through it. Here's where the magic happens. The areas that receive light and the areas that don't behave differently at the chemical level. Some parts become easy to wash away, while other parts become solid and remain. After this step, a precise circuit-shaped pattern is left on the silicon surface, almost like a stencil. Engineers then use this pattern to etch or deposit materials, creating the actual electronic circuits. In other words, photoresist doesn't become the circuit itself. It acts as a blueprint and a protective mask, allowing circuits to be formed with extreme accuracy. As chips keep getting smaller, this process becomes even more challenging. Modern chips use extremely short wavelength light, called extreme ultraviolet, or EUV, to create features measured in nanometers. At this scale, even tiny errors can ruin a circuit. That's why EUV photoresist is considered one of the most difficult and advanced materials in the semiconductor industry. Only a few countries and companies in the world have the technology to produce it.